Welcome. This quick video is intended to show you how to do some Halix programming. We will begin by just looking at the instruction set for Halix. There are lots of instructions that are typical of what computers can do. We will focus probably on 3 or 4 for this. First of all, your assignment is to add 2 numbers. The example is going to be to add 2 numbers that we read from the keyboard. So therefore, we need to look at instructions that deal with I/O. So the first 2 instructions are I/O. And let me explain what happens. The read instruction has what's called an opcode of 0, 1. It is a number which identifies what the instruction is. And the instruction reads into the data memory. So the Halix computer basically has 3 parts. It has an instruction memory where the instructions are stored. It has a data memory where your variables or where your data are stored. And then it has the internal hardware of the computer itself. We will see that the internal hardware is quite simple. It consists of several storage units that are called registers. So let's see what happens when you read. When you read, the user is prompted enter data. The data is read and it is stored in the data memory at the location specified in the instruction. Locations are identified by addresses, and addresses are 2-digit numbers from 0 to 99. Consequently, the Halix computer can hold up to 100 instructions and up to 100 values. That's the limitation. So let's see what the machine instruction is. So when you construct the machine instruction, it becomes a 4-digit number. The first 2 digits for read are 0, 1, and the last 2 digits are the address. So we've laid out memory here. We've said that the variables that we read, N1 and N2, are stored respectively at addresses 0, 0 and 0, 1 in the data memory. When we compute the sum, we're going to need a variable for that, which we store at address 0, 2. So the 2 main storage units of the computer are the accumulator that you are familiar with. It holds values that typically are the result of operations that you've done. And this variable here, IP, is called instruction pointer, and it simply says, it's a finger that says, where does the next instruction come from? All right. So let's write the code first, and we will try to trace it. So the code for the first instruction is the opcode for read, which is 01, the address of N2, N1, which is 00. So the machine instruction is this 4-digit number. Similarly, the instruction here is 01, 01. All right? Now, when we execute these instructions, what will happen? Well, an input, suppose we have an input up here. Suppose we have an input. Suppose the first input is 17. Then when the instruction is executed, instruction 00 is executed, what happens? We will read the value 17, store it in address 00 in the data memory. So the data memory looks like that after the first read. Secondly, after we get the first instruction, the next instruction is the one that comes next. So after we've done this instruction, we do the next one. So the instruction address, so we do instruction 01, which is this one, which says read N2. And what do we read? Oops. Suppose we have a value over here, 23. So this instruction right here will read the value 23. So now that at the end of this we have 2 values in memory, and now we need to add them. Well, all arithmetic takes place using the accumulator. So what we need to do is basically do this. We need to put, okay, when this instruction is executed, we position ourselves to do the next instruction. Listen this up. Forget that for now. What we need to do at this step is to take 17, which is in variable N1, which is stored at address 0. We need to place that in the accumulator. What's the instruction for that? It's a load. So to load, we say the address and data memory, take what's there and put it in the accumulator. So the instruction down here, sorry for jumping around. Oh no, things cutting up. Is this. So what's the opcode? What's the 2 digits that say the operation is an 03? 03, we're loading from 00. After we do that, we can now add what's in the accumulator to what's in memory. So now I can add. Let's see how add works. Add, combine, add performs addition on what's in the accumulator, which is the left operand, and what's in data memory. So where is the value of N2? It's at address 01. So the add instruction has to be, what's the opcode? 0501. Notice that this is saying that after I add, here's the operation, but the result is saved in the accumulator. So what do we need to do next? We need to store the result in sum. So how do we do that? What's the address of sum? 02. What's the instruction for storing? 04. 02. And finally, we want to write the sum. How do we write the sum? The sum is stored at 02. What's the operation for doing that? Write 02. And finally, the last thing we have to do is really halt or stop. And the instruction for stopping is 99. All right? Now, what do we note? The file that we have to create is called an HLX file, Halix executable file. The file format is how many instructions. By now we know how many instructions, don't we? How many instructions? There are 1, 2, 3, 4, 5, 6, 7 instructions. We put the instruction list. How many data cells do we need? We need 3. Do we need to initialize them? Not really. So we can just put 0, 0, and 0. Okay, technically, if you're not initializing your variables, you do not have to specify data values. Notice that these last 4 lines refer to the data memory. All the lines above it refer to the instruction memory. So with that, we have our first program that will do some stuff. And if we wanted to, we could copy this, put it in our file, and run it, and you will see that this code will work. All right, with that, I'm going to quit. When you go into Codio, you have a program called Halix.run. To run it, it's like any executable, /halix.run, and give the name of your, I think it's add2.hlx. HLX says I'm expecting machine code, that is numbers. I'm not expecting any source file. So that's the end of this video. It went longer than I planned, but this tells you how to get started.